Hey guys, and welcome to your 10.4 notes. 10.4 is all about inscribed angles and polygons, so angles inside the shape. Okay, so an inscribed angle is an angle whose vertex is on the circle. Okay, so notice that the vertex of this angle is on the circle itself and whose sides contain chords of the circle. So notice that these sides of my angles create chords that go across the shape. So B to A and B to C, those are the chords. Okay. The intercepted arc is the arc that is between those two lines. So notice where that is over here. This is that arc. That red piece is the intercepted arc. It lives in between that angle. Okay. So what we're going to do first is actually talk about measurements of these arcs and these angles. So the measure of an inscribed angle is 1/2 of the measure of its intercepted arc. So you have a little formula over here, but the measure of the angle is 1/2 of the arc. Okay, so we're going to use that in order to help us find some measurements. So for this first picture, it says find the indicated measure. So first thing we're going to find is the angle. So remember, our angle today is 1/2 of our intercepted arc. So if I'm trying to find angle T, what I really want is its intercepted arc. So I'm going to look across the circle and I see that 48 is the arc. So since the measure of angle T should be 1/2 of 48, I know that the measure of angle T is 24 degrees. Okay, second one that I'm going to look at is trying to find the measure of arc QR. Okay. So QR doesn't have any angle that goes across from it, so nothing that I can directly tie to it. So what I'm looking at next is this part of my circle. Okay, so we learned in the very first section of chapter 10 that that is called a semicircle, and a semicircle is worth 180 degrees. So what that helps me figure out is if I know this part, I can find the measure of arc QR by taking 180 minus the measure of arc QT. Okay, so we're going to find that by using the angle right there. So remember, angle is 1/2 of the arc. So I know my angle is 50, and I don't know what arc QT is. Okay, so in order to find that, I would multiply by 2. So the measure of arc QT would be 100 degrees. So what I have to do now is to find the measure of arc QR, I'm going to take 180 minus the measure of arc QT, which we said was 100. So I get that the measure of arc QR is 80 degrees. Okay, down at the bottom, find the measure of arc RS and the measure of arc or angle STR. Okay, so what we're going to do first is figure out from this, I do have one angle right here that I can work with. So it kind of looks like an ice cream cone when you're looking at each individual part. Okay, so here's my ice cream cone. I'm trying to figure out what the measure of this arc is. So my angle is 1/2 of my arc. And if I know my angle is 31, okay, my arc is twice that. Okay, so I'm times 2 times 2. So the measure of arc RS is 62 degrees. Okay, so RS right here is 62 degrees. And the next thing it wanted us to figure out was the measure of angle STR. So STR. And if I look, I made another shape that almost looks like an ice cream cone, very similar to what we did before. So remember, the angle is 1/2 of the arc. So now we know our arc is 62. So 1/2 of that tells me that the measure of angle STR is 31 degrees. Okay, so this is 31. So what do you notice about this angle? This 31, hopefully you see, is also the same as this 31, and that they share that arc. So both of those angles had the same intercepted arc. Okay. So that is explained in this theorem right here. It says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So in this picture, both of these angles, ADB and ACB, intercept this arc. Okay, they both intersect arc AB. So both of these angles are congruent. Okay, so if they intersect the same arc, then they are congruent. Okay, so find the measure of the red arc or angle. So here is my angle. Okay, this is red in here. So if I know that, remember, my angle is 1/2 of my arc. Okay, for this one I want 1/2 of 90. So the measure of angle HGF is 45 degrees. Okay, next one right here, I have my arc that I'm trying to find. So my angle is 38 degrees. That's equal to 1/2 of arc TV. So we multiply by 2 to figure out what the arc is. So I know the measure of arc TV is 76 degrees. Okay, and the last one here, this is based off that theorem that we just learned. Okay, so both of these have the same intercepted arc. So if this angle is 72, this angle is also 72. So the measure of angle ZXW is 72 degrees. Okay, what we're going to talk about next are inscribed polygons. So a polygon that is inscribed or inside the circle. So all vertices of the polygon should lie on the circle. So that means all of the points of the shape are somewhere on the circle. There's my inscribed polygon. And the circumscribed circle, circumscribed just means around the outside. So that is the circle that contains those vertices. Okay, the two shapes that we're going to talk about are a right triangle and a quadrilateral. So an inscribed right triangle looks like this. Okay, notice it's probably not what you thought it would look like. Okay, it says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter. So this right here is my hypotenuse, which means across from that over here is my right angle. Okay, so that's what it would look like if we inscribed a right triangle. Okay, a hypotenuse will always be the diameter. Across from that is your right angle. Then the other shape we're talking about is a quadrilateral. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So remember, supplementary means that they add up to 180. Okay, so opposite angles are not congruent here, because that would mean that I have a parallelogram, and I'm not going to have a parallelogram inside a circle. Okay, so the opposite angles are supplementary, meaning these would add up to 180 degrees. Okay, so let's start with one of our triangles. Okay, this is our right triangle. So here is my hypotenuse. Okay, and across from my hypotenuse is my right angle. So if I'm finding the value of that variable, I know that angle right there should be 90 degrees. So if I set that equal to 2x and solve for x, I'm going to get that x is 45. Okay, next shape is an example of a quadrilateral. So remember, opposite angles are supplementary, which means z plus 80 should equal 180. So the measure of angle z, 180, not 1080, right, is 100 degrees. And similarly, okay, y plus 120 is 180. They're supplementary. So the measure of angle y is 60 degrees. And we're going to try two more of those. So here I have a couple more variables in each one. So this first one, I have my triangle. Remember, this is the hypotenuse. So across from that should be my right angle. So that tells me that x is 90 degrees. And then I know that this is 90 and this is 40, so the last one I need to find is y. So I have 90 plus 40 plus y equals 180. Remember, all angles in a triangle add up to 180. So that means that y is 50. Okay, and our last shape here, remember, in a quadrilateral that's inscribed in a circle, opposite angles are supplementary. So I'm going to have 2c minus 6 plus c equals 180. I'm going to combine my like terms, so I have 3c minus 6 equals 180. Add the 6 over. So 3c equals 186. And when I divide by 3, I get that c is 62. Okay, and the last thing I need to solve for is my x's. So I have 10x plus 8x equals 180. I'm going to combine my like terms to get 18x equals 180. And when I divide by 18, I get that x equals 10. Okay, your homework is on Clever, so make sure you're asking questions if you get stuck on anything, but that is all for 10.4.